All right, this is simplifying rational expressions through factoring. We just got done covering how to factor polynomials, and I showed you every possible way to factor different types of polynomials, whether it's a trinomial or a binomial or the difference of squares. I showed you different things, and so what we want to do is take it to the next level of reducing a bigger math problem that they're called rational expressions. And so what we want to do is simplify it. So just let me remind you, like, back in the day when you had to do, 2, divided by 4, something like that, and then you found some number in common, which is a 2, and then back in, like, when you first started reducing, you divide by 2, and then you reduce it, and that's going to be 1/2, right? And sometimes, even if you had like 5 over 5, they simplify to 1. They don't literally just disappear. They don't. Some students, they think they cross out and they disappear. They don't. You actually divide by 5. You divide by 5, and that's why it's 1 over 1, which is 1. So you cancel like that. Now the other thing is, once you move up to the algebra level and you start coming up with expressions, you're going to be left with something like this. And students often are tempted. They see 2 divided by 2 right here, and they're tempted just to cross them out and say the answer is x. But that's not what you can do. You can't do that. And I want you to think about it. So, like, for instance, if I had 2 plus 3 over 2, now I know the answer is 5 over 2. That is the answer, because if I add the tops together, I get 5. So the answer is 5 over 2. So think about it. Could I cross out the 2's right here? Could I do that? Well, no, but if I cross them out, I would end up just with the answer 3. And I don't get the same answer. So you can't just cross out. Like when I'm adding something on the top or on the bottom, you can't just cross out part of it. Okay? Remember what this big, long division bar means? This big, long division bar literally means I'm dividing the 2 by 2, and I'm dividing the 3 by 2. So that's literally what it means. You can't just cross out one of them like that. So in other words, this plus sign kind of glues these things together. So let's look at this problem from here, from this perspective. So again, you might be tempted, some students might be tempted, they see x squared over x squared, so they might be tempted to cross those out, but you can't do that because they're literally, you have a whole expression here that's being subtracted together. And the same thing with the numerator. It's a whole expression. So you're supposed to take the entire top expression and divide that by the entire bottom expression. You can't just literally cross out part of it and then divide what's left over by what's left over. You can't do that. So you say, well, how do I simplify this? Well, factoring is actually going to play a role in this. So if you factor the numerator, and again, you should be getting quicker at this. This is a 1 out front, so what times what is negative 15. It multiplies together, that gives you negative 15, but then adds together to give you negative 2. Well, that would be x minus 5 and x plus 3. And again, you could FOIL that to check. Now let's look at the denominator. The denominator is a perfect binomial, and we just got done talking about perfect binomials. The first term is perfect, the last term is perfect, so these are going to be literally opposite sides of each other. So x times x is x squared, 3 times 3 is 9. And so I factored the top, I factored the bottom. Now what could I do? Well, if you notice that these two are exactly alike, x plus 3 and x plus 3, they are literally exactly alike one another. So these two can cross out because the entire expression equals one another. So you can cross those out, and that's all you can do. So on the top you have x minus 5 and then x minus 3, and let me emphasize that is all that you can do to simplify that. Again, some students might be tempted, and again, it's wrong, but some students would be tempted like, oh, x divided by x, so they would be tempted to cross those out and say the answer is positive 5/3. Again, that is not correct. You can't simplify part of an expression. And so the answer, this literally is like that. Okay, you can't cross out part of x minus 5. The entire thing is being divided by the entire thing, and that's all that you can do on that. So let's look at some more possibilities. And again, I'm assuming that you know how to factor. So let's just factor each one of these. So the top is already factored, which is x plus 4. The denominator is a perfect binomial. So this could be factored to x plus 4 and x minus 4. Again, binomials have opposite signs. And so notice what could cross out now. The exact expression crosses out. Now again, be careful when you have this, because some students, all they see is x minus 4 and they just write the answer as x minus 4. But remember, if I had 5 divided by 5, they don't literally disappear, they literally reduce to ones. So even though this crosses out, there's still a 1 up top, and then you have x minus 4 still remaining on the denominator. Let's go to the next expression. Again, 4 is all by itself at the top, and then you have x and then x plus 2 on the bottom. Well, then you look at the expression and like, well, there's nothing alike. Well, that's correct. There is nothing alike, so this actually is the answer. That's not a trick question. That's just a matter of recognizing like it is already in its simplified form. It's kind of like the math teacher in elementary school say reduce 1/2. Well, it is reduced. You can't reduce 1/2 anymore, so that is already reduced. So let's look at another illustration. Again, we have a trinomial that we're going to factor on the top, and that would have to be x minus 3, x plus 1. And again, I'm assuming that you remember how to factor trinomials. And so on the bottom, you're going to get, factor this trinomial, you're going to get x minus 3 and x plus 2. And notice the exact expression, x minus 3's can cross out. And then what remains is x plus 1 over x plus 2. And again, that is your answer. It cannot be simplified anymore. So let's look at one example that's a little bit more involved. So remember back when you started dividing fractions, and you had something like 4/3 divided by 5/9, something like that. Well, the way to divide fractions is you change it to multiplication, and then you flip the following fraction. So the following fraction, the second fraction, gets flipped. And then after that, you can start, canceling. So you see, anything on the denominator can reduce when it's multiplication. Anything on the denominator can reduce with anything on the top. So 3 goes into 3 one time, 3 goes into 9 3 times. And then after that, you can multiply. So that's what we're going to do here. We're going to literally change that division sign to multiplication and then flip the following fraction. So that's the first step is, switch it from division to multiplication and then flip the following fraction. Now after that, you're gonna look at each part of the fraction. So at the top here, I have 7x, and that can't be simplified anymore. Now look at 2x minus 10. So look at 2x minus 10. How can this be simplified? Well, notice there's a GCF involved. If I factor out a 2, I get x minus 5. So let's look at this fraction. So I always tackle the numerators first, so typically I do. And so let's look at the trinomial. And so this right here, again, look for what times what is 30, positive 30, but it has to add together to be negative 11. So that would be x minus 6 and x minus 5. Now let's look at this denominator. So how can you factor this? Well, notice there's a GCF involved. There's an x and then an x minus 6. Now, once you're done with it, you start looking for things that can simplify. Well, again, anything up top with anything on the denominator, because I'm multiplying, I can reduce. So I see x minus 6's that can cross out. I also see x minus 5's that can cross out. And then there's one other thing. There's an x with another x that can cross out. So notice, what do I have left on the numerator? I have a 7 on the numerator, and the only thing I have on the denominator is a 2. So the entire polynomial expression simplifies to 7/2.